What's poppin', dogs? Mr. Allen here with some ACT prep. For this one, we're going to focus on some linear equations, inequalities, as well as systems of linear equations and inequalities. Now, a lot of these you might actually find kind of easy, but that doesn't mean you shouldn't practice them because you want to get those easy points. So let's get it started. So one of the following is an equation of the linear relationship shown in the standard xy coordinate plane below. Which one is it? They always love to say that standard xy coordinate plane. They're very formal, okay? Well, the key things that I'm going to look at will be my slope as well as my y-intercept for this one. And it looks like my y-intercept is right there between 4 and 6, so I would say the y-intercept is 5, which means it's got to be choice, whoa, that's a terrible circle there, choice E, okay? Now, what's another key feature here, guys, is my slope being 2. It's a little bit harder to see, actually, on this one because there's no real grid there, but I could maybe start here at the 5, and I'm going to go up 2 over 1. Then we can see here that if I were to draw like a vertical line in here, that it is, right between the 0 and the 2. So it looks like we went over 1 after going up 2, okay? So that matches my slope, but it's way easier to see our y-intercept here, and the only choice was E with that. If there was another one with plus 5 as my y-intercept, then I would need to look at that slope as well. Cool? Awesome? Dope. All right, so what is the slope of the line represented by the equation 6y minus 14x equals 5? Well, what's the easiest way for me to find my slope in a linear equation? If I am in the wonderful slope-intercept form, y equals mx plus b. What a classic, right? So I'm going to rearrange this thing, right? First thing I'm going to do is I'm going to add 14x to both sides. And let me just copy this thing down. 6y minus 14x equals 5. So we'll add 14x to both sides. So I got 6y equals 14x plus 5. And now I'm going to divide by 6 on both sides. And when I do that, I'm going to get, let's see here, 14 over 6. That's not a choice. But I can simplify this. They're both divisible by 2, which makes that 7 over 3x. I already see my answer. I don't even care about that y-intercept. My answer here is choice H. That is my slope. All right, so rearrange it into slope-intercept form. Easy to spot it from there. Hope that helps, dogs. Which of the following systems of inequalities is represented by the shaded region of the graph below? All right, well, I've got all solid lines on this graph, so it's all going to be less than or equal to or greater than or equal to. That doesn't eliminate anything here. I'm going to look at my vertical line first. I feel like that's the easiest one to look at, okay? So if I look at my vertical line here, I'll highlight it in green. It is shading to the right-hand side over here, okay? That little spot there that we see, that means it's shaded always all the way to the right, okay? So it's got to be x is greater than or equal to positive 3. Well, unfortunately, 4 of them have that, but E does not. So we can get rid of E right there, okay? Now, what about the other line? So let's look at this guy here on that slant there. It's got a negative slope. All of those have a negative slope, so that doesn't eliminate anything. But it does need to be below it, so it's got to be less than. How did I know that? Well, if I think of this as like having some arrows pointing down, less than, that is where my shaded region is, right? It's below that line. So I got to have y is less than or equal to negative 2x. They're all the same equation here. So let's eliminate the greater than or equal to negative 2x's. So now I just have A and B. And because I'm shading between those two there, it is going to be an and statement rather than an or statement. So my choice here is choice A, right? It is less than or equal to negative 2x, right? Y is less than or equal to negative 2x. And it's also greater than, x is greater than or equal to positive 3. Both things are happening in this shaded region that we have right here. Cool? So choice A is the answer. That's dope. Moving on. What is the x-coordinate of the point in the standard xy coordinate plane at which the two lines, y equals 2x plus 6 and y equals 3x plus 4, intersect? Interesting. So it's only asking for the x-coordinate, and that's actually super awesome. Because if they're both equal to y, I can just set the other sides equal to each other. So we're going to have 2x plus 6 equals 3x plus 4. And now I'll subtract 2x on both sides. I get x. I'm going to subtract 4 on both sides. And we get 2. Boom. Choice B. Easy peasy. Easy peasy. Easy points is what that is on that ACT. Ooh, we got a system of equations on this one. Let 2x plus 3y equal 4 and 5x plus 6y equals 7. What's the value of 8x plus 9y? Now, sometimes on these problems, there's a way to like just double or triple one of the equations and you'll get the answer. However, that's not the case this time, so I'm just going to set up and solve using elimination method. So I'm going to stack these two. We got 2x plus 3y equals 4, and I have 5x plus 6y equals 7. Now, if I double the top equation and make it negative, so I'm going to multiply by negative 2 rather, we'll get negative 4x, negative 4x minus 6y equals negative 8. So I'm multiplying through by that negative 2 all the way through. That's actually, this is illegal math notation here, but I do math on the streets, dogs. All right, so now we're done with that equation, and I'm going to eliminate. So the 6y and negative 6y gone, and then I've got 5x minus 4x, that's just x, equals 7 and negative 8 is negative 1. So we've got x equals negative 1. That's a start. How do I get y? Well, I can take either one of those two equations and plug x in. I'll actually take the top equation. So I'm going to do 2 parentheses negative 1 plus 3y equals 4. This is going to be negative 2 plus 3y equals 4. And then I've got to add the 2, so get 3y equals 6. So let's divide by 3, and I get y equals 2. Okay, so those are my two values for x and for y. But I got to get 8x plus 9y. So we're almost done here. I'll throw in the negative 1 for x. So negative 1, and it's 8 times negative 1 plus 9 times 2. So that's going to equal negative 8 plus 18. So positive 10. Boom. Choice E. It's a lot of work. And maybe you didn't even remember how to solve a system in the first place. So hopefully now you do. But did you know there's an app for that? Check this out. You're going to hit, let me pull my calculator up. You're going to hit apps, okay? It's third one down, one over, kind of by the green alpha button. And then we're going to arrow down to option 9, it's polynomial and simultaneous equation solver. That second option there is simultaneous equation solver. I've got 2 equations. I've got 2 unknowns. And we're just going to go ahead and all those other ones are good to go. We're going to hit the graph button. You see how it says next right above the graph button? That's how you activate those. And now I can just type in my equation. So 2, enter. I'll keep it positive because it's positive. 3, enter. It equals 4, enter. 5, 6, 7. And now I'm going to hit solve. Make sure you hit enter on that last one so that the 7 is registered. Hit graph. Boom. Awesome. Now I've got my two answers. As easy as that. So probably a little quicker in the app unless you see something like standing out at you in the equation that it's easy to solve. But know that that simultaneous equation solver is right here in your calculator, which is super helpful, especially if you didn't remember how to do it in the first place, or just to save a little bit of time. All right, so this is an interesting one here. We got point A is to be graphed in a quadrant, not on an axis of the standard XY coordinate plane below. We got all of our quadrants, 1, 2, 3, and 4, okay? And they actually label it out for you in case you didn't know which one was which. It says, if the x-coordinate and y-coordinate of point A are to have opposite signs, then point A must be located in which quadrant? And it could be multiple quadrants. Well, let's see here. In quadrant 1, everything is positive, so they're going to have the same signs, okay? In quadrant 3, the x's are negative and the y's are negative because it's negative x's over here, negative y's down here. But in the second quadrant, my x's are negative while my y's are positive. And in quadrant 4, my x's are positive over here while my y's are negative down here. Maybe I make this more of like a positive. There we go. That looks better. Okay? So it looks like it's 2 and 4. Is that an option here? Oh, yes. Choice E. 2 and 4 only. So that's where they're going to have opposite signs. If it said where they're going to have the same signs, it's going to be 1 and 3. Cool? All right, a little bit of a weird problem there. Not like any math, just kind of thinking about things in generalities, which can honestly be confusing at times. But anyways, dogs, I hope that general review of linear equations, linear inequalities, and systems of equations and inequalities, as well as a little handy app action here on the TI was helpful for you guys. If you liked it, like it, subscribe, comment if you guys have any questions or just have a request for a style video or a style problem. I'm happy to make one for you guys. Otherwise, thanks for watching and have an awesome day.